What if you could turn thousands of messy rows into a clean summary table? In this video, I'll show you how to reshape, merge and join Pandas data frames using the functions you'll use in almost every real data science project. So, getting right into it. We have the data frame, which stores data on people's salaries, their gender and department. Data I picked out of thin air. As we can see here with the data, first thing we're going to go through is what is called a pivot table. It is a way for us to turn a large data frame into a more summarized table. So, the main attributes of the pivot table is moving one of the columns to the index or row names, one of the columns becomes the column names, and then the last column becomes the values. So, for our example, write pivot equals and then pd.pivottable, then the data frame we are using. The values of the table will be our salaries. The rows or index will be the department and the columns will be the gender. Let's just see the table now by printing it so you can see visually a pivot table creates and how it can display data much more summarized and cleanly. The salary values that we don't have data for will show up as missing values, NA, and the values with multiple entries such that we have 3 salaries in the original data frame for males in IT department. As standard, the pivot table will take a mean and return that as our value. Seen here, 41,000. Now, what if we want these summary tables a little different to our liking? Well, we can do 2 other things. First, we can choose the method of which the values are summarized. As standard, it will be the mean, said before, but we can change it. For my example, we will change it to the median. However, we can change it to sum, count, min, max, standard deviation, and variance, to name some helpful ones. We can also change the value of missing values with fill_value. For this example, we will set it to 0, leaving our next pivot table as follows, with the missing values now being zeros and the 41,000 mean is now a 40,000 median. Now for the opposite, we use melt to unpivot a table. This will take an identity variable that will be used as the rows. This will then take every other variable for that and show its value next to it. So if I melt as id_vars department, we see the department as the constant variable we're going through. Then it will go through every variable and the value of that variable for that entry of department. Now, what other things can we do with this? We can add value vars, which will be a list of the variables we want to go through. So if I only want to go through gender in the variable column, I place gender in there, so we only see gender in the variable column. We can change the variable column's name if we don't like it with var_name, and also the same for the column's name. As you can see here, our changed unpivoted table, which admittedly is not as nice looking as the pivot table. What is up next? Well, merging data sets together by a common variable. So we have a new data frame. It gives us our original departments, the variance of the salaries we have. We can now use pd.merge on df, info, our new data frame, and on equals, so the thing we're going to be merging by, which in this case is department. Now from the table we merge in our salary variance. This is an inner merge. If we wanted to change it to a left or a right or an outer merge, then we use how with how equals right, for example, to do a right merge. We can also merge 2 columns with on if they have different names but the same values, with left on and right on, by inputting the column names for both the data frames. This example, I create the same data frame to merge as before, but change department to area. Then when it comes to merging, I do left on department and right on area. Results show that the values in area and department are merged and the same while adding the same variance column. The next thing to go through is concatenating using concat. This is a way to join two data frames together, which is very simple. Take this new data frame that adds two new entries with finance and marketing departments, then using pd.concat and the two data frames in square brackets, this will, as you can see, just add the data frame on. One little thing you can add is ignore index equals true, which will reset the index for you. So instead of it adding the original index, as in the first result that shows zeros and ones near the bottom, it will reset it, and that will go all the way up to 7 in this example, which you can imagine can help with presentation and sorting. Finally, cut is a very useful to quickly categorize a column. So let's show this straight away, as I feel it's easier to show than explain. So create a new column called, for this example, salary category. Then we use pd.cut on our data frame and square bracket in our salary value, as these are the values we will be categorizing. So we place in our bins. For this we have anything lower than or equal to 30,000. Then that will set to low. 30 to 40,000 is median, and 40 to 50,000 is a high salary. So now label the categories with those labels, low, medium and high. Side note, if you want to have, for example, low to be 0 to 30,000 not included, we place in right equals false, as standard it is true. So if that didn't make any sense, hopefully showing you this table does show what I mean. We now have a salary category column that gives every salary a category of either low, medium or high, based on which bin it falls in. This is really helpful, as lots of the time without pandas this would require a lot of if statements. And that is everything we're going to go through today. I hope that all makes sense, as that was a lot. If you learned something from this video, please like the video and subscribe to support the channel, and I hope to see you in the next video.